Hello, my name is Chendur Jayavelu. I'm an incoming junior in high school, and today we're going to be looking at question 42 of the April 2021 ACT Math section. So let's get to it. So 42 was part of this table question from 41 to 43. I've explained question number 41 and the table in the previous video, so go make sure to go check that out. But now let's read question number 42. The figure shown below represents the route traveled on July 16th. Aaron started at the office, drove 70 miles due north to the first stop, then 40 miles due east to the second stop, and then 105 miles due south to the last stop. On his return trip, Aaron drove a straight road from the last stop to the office without stopping. Given that Aaron drove at the truck's average speed, which of the following values is closest to the time in hours drove on the return trip? So try to solve this on your own by pausing this video, and once you try at least something, then hit playback again. Okay, so basically this is a very cheeky problem, as you might say, but we need to find this distance, right? In order to find that distance, it's very sly. And you can only really do this. This is only one way which I can think of. Basically, what you have to do is you have to realize, hey, okay, this is, you're going north. You're going. I'm gonna draw a compass here actually. So you have north, south, east, and west, right? Basically, all of these directions are 90-degree angles from each other, right? So 90-degree angles, right? So what we can do is you're going, it's a 75 miles due north to first stop. So you started from here and you went north and then you went east, right? So you went from north to east, so that's a 90-degree angle. That's a 90-degree angle right there. And then here he's traveling in some random direction, we don't know for sure, at this position. But what you could do is you can create a triangle. Wow, this is so basically you're just recreating shapes here, right? And basically because this is a rectangle, right, all 4 degrees are 180 degrees, right? And this line right here is a straight line, right? So it's a straight line. Okay, angles, basically angles add up to 180 in a straight line. So if this is 90 degrees, then the total is 180 degrees, so this also has to be 90 degrees. And what we're left with, right, is if you see very closely, is we're left with a 90-degree triangle, right? So rectangles, opposite sides are the same. And a rectangle in a rectangle. So basically, if this is 75, then this bottom side, okay, I'm just going to pick a different color here. If this is 75, then this also has to be 75 down here. So 75 right there. Or my bad, I did not know that's actually 40. That is 40, my bad. This is 40 up here, and this is 40 down here. Okay. Then basically now we want to find this side, right? Basically we've given a right triangle. So we found that one side is 40, and we need to find this side down here at the bottom, right? And at the bottom, that's here. Let me color code this better. So this green, this is the 40 side right there, and now we need to find this side. This red side is going to be our bottom thing right here, and this triangle down here. How we figure that out is we can just use some simple subtraction, right? So basically we drew a line through this rectangle, and this entire thing is 105. So, and this smaller section right here is 75, right? Which means this red section is red is equal to it's basically equal to black, right? Black minus green. And you can see through this picture, if you take this entire 105 and you take this 75 portion out of this, remember opposite sides are exactly the same. So if this is 75, this is also 75. So the small portion is 75, the entire thing is 105, which means the remaining over here is 30. which means, okay, now we have a right triangle, and with Pythagorean theorem, right, we can call this C, and then we could use our Pythagorean theorem to figure out that side. So C squared is equal to A squared plus B squared. C is our hypotenuse, right? So A and B are our sides, so we can say that's 30 squared plus 40 squared. And if you do the math, that's 2500. So if C squared is equal to 2500, then C is equal to 50, right? So the amount of distance that he has traveled is 50. So we can put this in our diagram right here. And now what we need to figure out is the amount of hours Aaron drove on the return trip, right? So let's see if we can get any information on here. Okay, yes, we do get some information. When moving, the truck traveled at an average speed of 50 miles an hour. Perfect. So if you know, it's a very handy formula. So distance is basically equal to velocity times time. So if you take the speed of something and you multiply it by the amount of time it takes, you get the distance. So here we have 50 miles is traveled from the last stop to the office, and yeah, let me make that better, 50, and the speed is 50 miles an hour. And if we do the division, right, then we get 50 miles an hour. Here, let me zoom out a bit. We get 50 miles an hour multiplied by 1 hour for 50 minutes is equal to time, and the minutes cancel each other out. Or sorry, not 50 minutes right here, 50 miles, making a lot of mistakes. 50 miles down here, and the 50s cancel each other out, and you're left with t is equal to 1 hour, which means the answer is H. So that is a really lengthy problem. Thank you for sticking with me. Hopefully you'll stick with me as well with question number 43. Until next time, I'll see you later. Thank you once again for watching. Bye.